Hi, welcome to Mr. Brudz's 7th grade science class. Today we will be talking about chromatography. So the purpose of today's lesson and activity is to focus more on just a review of what we learned about mixtures, particles, and kind of put that into practice. So chromatography. So I actually have done a lot of chromatography in my life in my previous jobs. So Brandon, when you see chromatography, so we know graphy means the analysis of. What are some things that you see when you see the word chroma?
Well, I think colors.
Colors, okay, that's a good one. What are some other words that come to mind?
Time.
I think you're thinking of chrono.
I am. I'm just looking at CHRO. That's all that comes to mind for me.
So we covered the word chromatic. So what's something that's chromatic?
Light?
Light, yes. Okay. So chromatography is, so the definition of chromatography is separating something through a medium, and analyzing something as it goes through a medium. And so we covered solution, so solute and solvent. And so I think you have a medium in front of you right now. What would you call that medium?
Water.
Water, okay. And so if we're going to be making a solution, what is the solvent? If solvent's doing the dissolving,
Is it the water?
yes.
Okay.
And so the solute would be
Whatever I put in the water?
whatever you put in the water. Good. Alright. So there's a lot of different ways you can do chromatography. I've done gas chromatography, liquid chromatography. There's also light chromatography. And so today we're going to be putting it into practice. So I have in front of you some markers, a cup of water, and some strips of tissue paper.
Okay.
And so today we're going to do a little test so you can kind of see in practice what chromatography looks like. So, alright, so you have 4 markers right there. So if using the tools I've given you, how would you analyze the contents of those markers?
Just like in a bubble, how would I look at the contents?
Yeah.
I would Google them.
Okay, Googling.
Yeah.
Say you didn't have access to the internet and you have what's in front of you. What are some ways you can analyze the contents of the markers? And it doesn't have to be fancy.
Well, none of these have ingredients lists on them.
Right.
So I guess this would have something to do with putting them on these strips and dunking the strips in water.
Okay. Alright, do you want to do that?
I guess.
Yeah. Alright. So you have the strips, you have the markers. Okay, so you said put marker on the strips and put the strips in the water. So why do you think that would happen? What do you think is going to happen when you put the strips in the water?
I don't know.
Okay.
I would assume that the larger particles will stick to the bottom of the strip,
Okay.
and the smaller particles will move to the top with the flow of water because they'll be easier to move.
Okay. Alright, and so that is what we would call, looking at your word bank,
hypothesis.
Hypothesis. Yep, that's your hypothesis. And I like that you used words from the word bank like particle and flow. And all right, so when we're accounting for things on our test, we are looking for
A control.
a control. So I want you to tell me 2 things we can control for when we do the test.
The amount of water it's exposed to, and the time that it's given.
Good. Those are good examples of control variables. All right. So do you want to make up your strips?
Yeah, but these are dry erase markers. So how does this work?
All right.
I guess permanent marker.
Okay. So your strips. So when we said controlling for the amount of marker on the strip, explain your thought process behind this pattern. How do you think that's going to control for the amount of marker coming contact in the water?
I don't have a thought pattern. I just put some marker on a tissue.
Okay. So I notice on one of your strips you have 6 lines, and one of your marker you have 4 lines.
I do.
Is there another arrangement of marker you could think of that would more evenly distribute the marker to the water?
I guess I could just draw the same shape on all of them.
Yeah, all right, that's controlling.
Should I do that?
I would say that's a very good idea. And as you're doing that, can you tell me what you think we should do with the size of it?
Make them the same?
Right. And so when you make all of your marker that you're exposing to the water the same size and shape, then we'll expose a consistent amount, and that's another example of a variable you're controlling for. Grab scissors real quick. You can just cut that off. Alright, so I think you're just about ready to run the test. And there's one thing I want to think of. When you're placing the strips into the water, in what arrangement do you want to place the strips? As you're placing a strip into the water, how would you do it so they're all consistent with one another?
I don't know.
So, water's going to be traveling up the tissue paper. So, what is a way that you can kind of ensure that the water's going to hit the marker at the same time?
Put them all in at the same time?
Okay, you can put them all in at the same time. That would be good. What about the physical arrangement of the strips?
I don't know.
Alright, so... Alright, before you actually put it in, show me how you're going to put a strip in. Alright, like that. Alright, so if we put it like that, what do you think is going to happen to the marker if the water hits it all at once, if you put it marker side down?
It's gonna come off.
Right, so
and
how...
get diluted into the water.
Right, and we want to avoid that.
Okay. So I want to put them this way.
Right.
So should I have drawn my squares much lower then? Or rather much higher?
I mean, if you think the water is going to travel too slowly, you can make them shorter, but what do you want to do if you're making them shorter? What can we do to make it consistent and control for those variables?
Make them all the same length?
Make them all the same length. Good.
Is that something that I should do, or do you think it's not going to matter?
I think it's something you have the option of doing if you think it'll work better, so long as you're being consistent about it.
Okay, so out of character, if I cut these shorter, my plan was to put this here and then drape it over so that I didn't have to hold it.
Right.
If I cut them shorter, that can't happen.
Okay.
Is that going to matter? Is there a different way to do that? Should I
mean,
not drape it over? Should I just dunk them all in? Like, what's the thought process there?
Alrighty. Alright, so if we're having positional issues, instead of drawing draping it over sounds like a good way. If you're drawing a square on the top of the strip, what's another way you could do marker?
Another way I could do marker? I guess I could just draw a different shape here.
Okay, that works.
Yeah, okay.
Alright, so I think you're ready. So do you want to try and run it?
Sure. Do I put them all at the same time?
I would recommend that because time is another variable we have to control for. So actually, here, I'll help you with this part. You start and I'll follow your lead.
So I was just going to pick cardinal directions and then drape it over the sides after they get in there. Oh my god. Okay, so I'm good.
Alright, and then I'll match you so we're consistent.
Ready?
Yep. Okay.
Just give them a little bit of water.
Just. Okay. So. All right. So tell me what you're observing right now in the moment.
All of the water is very slowly making its way up the tissues.
Right. So this is what is called capillary action. When a liquid goes up thin tubes, the thin tubes being the fibers. So the water's traveling up towards the marker. So I want you to write down 3 predictions as to what you think is going to happen when it gets to that point.
Actually, this one.
Oh shit, well, you're way over time.
Yeah.
Alright, so you have the dots get lighter, and why do you think the dots are going to get lighter?
Because the ink is going to spread out and make them lighter.
Okay.
It's not as concentrated.
So the ink is made out of particles. What are the particles doing?
Flowing.
Flowing. Okay, that's good. Alright, so the dots will get lighter. Dots will get bigger. Okay, because you said they're
Yeah,
spreading
gonna
out.
spread out.
And then the tissue gets wet, which is an observation you've already made. All right. Well, thank you for your help, Brandon, and we'll continue this lesson next time.